Hey guys, welcome back. This is the second part of the day 8 notes. And now you can see here in example 7, we've got sine 2x equals square root 3 over 2. Well, what looks a little bit different here? The fact that we have a 2x inside the parentheses. The trig function is already isolated, but what this is going to do is it's going to change our period. All right, so far our domain, x is an element of 0 to 2 pi. So what I need to do now is figure out, okay, well, what's the domain for 2x? Well, that's kind of simple. Basically, what you need to do is just double both of these. So 0 times 2 is 0. 2 pi times 2 is 4 pi. So when we solve for this group, which is a 2x, I want all the angles between 0 and 4 pi. All right, well, where is sine square root 3 over 2? That's 60 degrees, so this 2x is going to equal 60 degrees, which is pi over 3. Well, don't forget, let's think of our quadrants. ASTC, sine is positive, where? First and second. Now we have to go all the way to 4 pi, so what we're going to be doing now is we're going to be starting here, get a first quadrant, get a second quadrant, and then keep going all the way around one more time. So basically I'm going to come up with these equations. 2x equals pi over 3. Well, in the second quadrant, that's going to be 2x equals 2 pi over 3. Well, how do I get the other ones? Well, remember coterminal. All right, so if I want to go all the way around and get another angle in the first quadrant, I'm going to add 2 pi to pi over 3. So in doing that, basically I'm adding 6 pi over 3 to that, so that's going to be 7 pi over 3. And now I need to do the same thing to 2 pi over 3. Add 6 pi to that, and that's going to be 8 pi over 3. So now what's left to do is I need to solve each one of these equations for x. So if you notice here, I've got 2x, which basically means I'm going to multiply both sides of that equation by 1/2, and I'm going to do that for all of my equations. So what that gives me here for x is the following. Pi over 6, 2 pi over 6, which you can simplify if you want to pi over 3, 7 pi over 6, and 8 pi over 6, which you could obviously simplify to 4 pi over 3. And there's your solution. Okay, so for our last example. So again, what you need to notice here is that this is not an x in the parentheses. It's a 1/2 x. So in this domain, x is an element of negative 2 pi to 2 pi. Well, what I need is 1/2 x. So basically then, you take both of those and divide them by 2, which becomes negative pi to pi. So now, I'm not solving for x, I'm solving for 1/2 x. And I want to find the angle where cosine is 1 over square root 2. Well, you should recognize that as a 45-degree angle. So I'm going to have 1/2 x equals pi over 4. Well, we always check quadrants. ASTC, cosine is positive in 1 and 4. Now, if you notice here, I have to go from negative pi to pi. Well, that's the only one I'm going to see between 0 and pi. And then if I go in the negative direction, that's the only one I'm going to see between 0 and negative pi. I'm not going to go all the way around the unit circle. So my other possibility here is going to be 1/2 x equals negative pi over 4. Again, we kind of talked about cosine. It's kind of nice that the way this works out. To solve these equations, very simply, I'm going to multiply both sides by 2. And that's going to give me x equals 2 pi over 4, or pi over 2. And x equals negative pi over 2, or you could say plus or minus pi over 2. Okay, so that's it for day 8. I know we threw a lot at you here. These two examples particularly are a little bit challenging. So in day 9, we're going to actually review more of this. So do what you can on the homework tonight. Please be sure to check the Schoology page for all answer keys and then don't hesitate to contact us with any questions.